And let's keep talking about assignability in TypeScript. So in the previous video, I talked sort of about a background of what assignability is. Now I'm going to talk about what structural type checking is. And we'll look at micro or mini-TypeScript to sort of see how it works. This isn't how TypeScript actually works. It's much simplified still, but this is sort of the abstract version of it. So let's go over to VS Code. So this is scented TypeScript, or like the 1/100th scale TypeScript compiler. It's considerably bigger than something you would have in a textbook, but it's still nothing like the entire TypeScript language. And our type is now a union. So you have primitive types, object types, function types, and type variables. Type variables are like type parameters from a generic type. And then let's look at those. So everything is based on simple type, still has an ID. It's now a number, and we'll increment that number inside the checker. But it's still just an ID. Primitive types have no additional information, so they're basically going to be compared nominally. Type variables are the same way. They just don't have a lot of information. They have a name, but they're basically compared nominally as well. And finally, object types and function types have contents, so you can compare them structurally. Objects have members, that's organized in a table of symbols, and functions have a signature, which is a set of parameters and a return type. So let's look at how the checker actually checks types for this larger language. So this language has strings, numbers, errors, and any. And again, error and any are sort of kind of the same thing in terms of the way that they compare. It's just that errors happen when you refer to a type that doesn't exist or something. And I should mention, like, the types for this language, the errors for this language are not particularly usable. They appear, but they're sort of cover a big span, and they don't have the fancy drill down capabilities that are in TypeScript proper, where we try to find the exact span and cut out any irrelevant elaborations or anything like that. Okay, so let's look at, again, it's checking a var statement. The code here is pretty much the same as it was earlier. Actually, we check expression on an initializer. So remember, if you have something like rx equals 1, you're going to check 1, find the number type, and then if there is no type name, then we're done. No checking required. But if you do have a name here, then you look up that name and check that type and so on. And then instead of using triple equal, we're now going to use is assignable to check. All right. However, you'll notice that is assignable to actually does immediately start off with triple equals. So you do a quick identity check still at the beginning of a structural check. And you also check for any and error, because if it's any or error, then anything goes. You're not going to do any further checking, so you just return true. And then primitive types also use triple equal. In fact, this code is technically redundant. I just put it in there because it was sort of finished out the set of possibilities. But now let's look at actual structural checks for objects. So let's look at an example here. So I'm going to say declare var a that just has a property a, and declare var ab that has a string b. All right. So thanks, Copilot. That's not actually what I want. What I want is a. Let's assign ab to a and say, okay, is that okay? Yeah, that's fine. Why? Because the target of this assignment is the important thing. It has an A property. Does AB have a property? Yes, it does. It also has a B property, but it doesn't matter. The only thing you can do here is A.A. You can't say A.B because that's not part of A's type. Conversely, if you have AB equals A, that's illegal. Why? Because this target is AB this time. And it has an A property and a B property. So when we check A, it has an A property, fine, but it has no B property. And the reason you want to do that is because you're allowed to say AB.A or AB.B. If you say to AB.B after this particular assignment on line 411, then at runtime that's going to be undefined, not number. And so the type system will be giving you the wrong answer there. So you have to put an error on the assignment. Let's look at how that actually is implemented in code. So again, the target's sort of the important thing here. You start off by looking at the target's members. You get the target symbol, so this is going to be, A for here. For this assignment, it's going to be A. And then you check it in the source to see if it exists. If it doesn't exist, you return false, and that will be an error later. If it does exist, then you check that they're assignable to, and basically it's a recursive call. So once you've found another A that matches, you pass string and string and recur on string and string, which of course are triple equal. So you're done. But that could easily be another object type, in which case you'd have to do a recursive check. So that's objects. You're basically doing a loop over the target's properties. All right, let's look at functions now. So I'm going to move this down here so that I can see it on the screen. Yeah. And I'm just basically going to turn the curly brackets into round brackets here. Okay, now we've got functions. Great. Functions are interesting because they kind of end up working backwards. Let's look at the code first. Actually, I don't actually want to look at type parameters because this is not, strictly speaking, sort of related to assignability. If you have type parameters on a generic signature, you have to instantiate them and then you can compare them, because then it's no longer generic because it's been instantiated. We can talk about that some other time. What I want to look at is this the calls to is assignable to. So here we're checking the return type first. So if you've got a signature, you check that the source's return type is assignable to the target's return type. So in this case, if you're assigning AB to A, you need to make sure that Boolean is assignable to A. That's so far pretty much like an object type. Where it begins to differ is parameters, and you check the parameters length. That kind of makes sense because instead of having a set, you have a list of parameters. So a set of properties for objects, list of parameters for signatures. But we've flipped it around. We're now checking that the source parameters have a match in the target. And in fact, when we do our recursive call to assignability, we're checking the properties of the source rather than the target. And that seems weird, and in fact the errors have flipped around as well. So why is that? Let's take a look. So before we do any assignments, if you call A with, say, A, whatever, that's fine. You only have to pass one thing in. Now if we assign AB to it, according to the type system, you still only have to pass one thing to A. However, if this is actually aliased to AB, you have a problem because you didn't pass B, and the thing that A is actually AB now, you've just passed undefined as the second parameter. But of course, the type system tells whoever implements AB that B is going to be number, not undefined. And so you cause the type system to lie to the person who implemented AB, basically. So what you actually need to do is check to make sure that AB, when assigned to A, so when AB is the source, you need to make sure that all of the parameters of the source have a match in the target, which is backwards from how objects worked. And that's because parameters compare contravariantly, not covariantly. I don't really want to talk about variance here, but that's what's happening, is that the variance is flipped, and so the direction of the comparison has to flip as well. So like I said, now we're going through every parameter of the source rather than every parameter of the target, the way you kind of expect. And you can see it works the other way around as well. So let's get rid of these calls, get rid of that. So if you call AB with, A1, thanks Copilot, that's a legal call. You can actually also do this. One is extra there, but it doesn't actually hurt anything. So if you call it with AB after you assign A, that's fine, because A only requires one thing, and it's provided. And yeah, sure, there's another thing provided, but it doesn't matter. It's going to ignore it. So in that case, we actually do want the assignment to work. All right, and so that's a sort of an overview of how structural assignability works. Next time we'll talk about how TypeScript actually works, and it's, as you can imagine, much more complicated. And I will see you in that video.